Hello, welcome back to my channel. Now what we have in front of us here is a Mosfet amplifier I built for a friend 30 years ago. I did do a video on this last summer, but refurbishing it last summer, that was. Changing, nasty. Don't want scope probes touching it, and they shouldn't because it's live. And it runs on plus or minus 50 volts, so there's a fair bit of energy stored up in these big capacitors that will ruin your day if you short them out, and it will probably ruin your amplifier as well. But what we have here is back in the early 80s, late 80s, early 90s, Maplin Electronics produced these circuit boards. You could buy them as a kit. Got all the components, you got the circuit board, you got the L-shaped bracket which would mount onto a heatsink, and they were a fairly cheap way of producing a high powered amplifier, roughly 100 watts a channel into 8 ohms. And he used it for a while back in the 90s and he's quite happy with it, but then it went into storage for many years, and he wanted to use it again fairly recently, but he was complaining of hum on his speakers, and he's got the two speakers on his desk either side of his computer, so he's fairly close to the speakers. So yeah, if you're going to hear hum, you're going to hear them in that situation. So I brought it back here and I did some measurements on it, and sure enough, on my Celestion Ditton 44s, yes, there was quite a bit of a hum if you put your head next to the speaker, but if you sat 6 feet away from it, you wouldn't hear the hum. So in a normal room, I don't think it was a problem, but even so, it shouldn't hum. No amplifier should hum unless it doesn't know the tune, or the words I mean. Anyway, so I've done further investigations on it, and I did some measurements which I've got here. So initially I was having problems measuring the hum level because it was too low to get a decent reading on my oscilloscope, 2.9 millivolts into 8 ohms. Since then I've discovered another mode on the oscilloscope which means I could measure that. So I was getting 2.9 millivolts anyway, and that was measured on eventually on a HP bench meter, digital high performance meter, you know. And doing the calculations, you get 1 microwatt, which sounds like a small number. 1 microwatt of hum. Wasn't sure if it's 50 or 100 hertz. I think it was a combination, but whatever. But 1 microwatt with very efficient speakers like mine, you can still hear it quite clearly if you stick your head next to the speaker cones. So I fiddled around for a bit, and I should have documented all this on video, and I made various changes to the amplifier, and as you can see, the noise level is gradually decreasing over time, and I wish I'd written down what I'd done in all these different measurements. But the main factors I found was, I think I will turn it off for a minute when I'm poking, was signal cables coming in from the phono sockets were too close to the toroidal transformer. Well, this one has got no way really around that, but it doesn't go right across in front of the transformer as such. But for the right hand channel, the signal cable was going through the wiring loom, which you just about can see there, and it was running all the way across in front of the toroidal, and it was picking up a lot of hum. So I moved well, that one I moved to the back of the box as far away as as far away as I could get from the toroidal transformer, and that was the biggest improvement I think I made by doing that. I also found that this thing had too much gain, this amplifier, and ideally you'd have a potentiometer on the front, the volume control. That's what I did with another one I made. So I made this little circuit board up with a couple of pots on it, so you can set the gain, and you can't vary it like you would with the volume control, but at least you can turn it down a bit. It was tending to go unstable at high volume levels. The other problem I didn't notice straight away was, this is going away from hum, I was getting some instability. I was getting something like 15 megahertz oscillation on the speaker outputs. Now, I eventually tracked that down to the Zobel network, which consists of a 4.7 resistor in series with a 0.1, which connects to the speaker output on the board, and the other end of the resistor goes down to earth. In fact, I'll get the circuit diagram. I'm not very well prepared today. Okay, here's the circuit diagram of it, and you've got your MOSFETs, which provide your main power output, and then you've got your voltage amplifier stages, which has got a gain of about 33 times voltage gain, I believe. So yeah, I was talking about the Zobel network. Well, that resistor completely burnt out, 4.7 ohm. I hadn't spotted that before, and I'd forgotten all about Zobel networks, what they were for. Apparently they're to compensate for the inductive reactance of a speaker at high frequencies. That's beside the point. They also give it some stability as well against oscillations, I guess. And having replaced that, I got rid of the 15 megahertz initially, but at times it was still unstable. So whether I did the right thing or not, I had another Zobel network after this coil, which is just a coil of wire inductor. It's a very small inductor. I added another Zobel network on that, and that tamed it completely. Now it does not oscillate at all. Other things I did to it, thinking that the hum problem was 100 hertz coming off the power supply, I thought, well, we want to give as clean a supply as possible on the voltage amplifier part of the circuit. So I cut the track on the negative and positive rails, stuck a 10 ohm in there and 100 microfarads and a 0.1, I haven't put the 0.1 on, down to earth. The theory being that you keep the noise to an absolute minimum, or ripple, because the ripple is quite large at this point. Keep it down to zero more or less, and it is now virtually nothing at that point. But I don't think that made much difference from my memory to the hum level. So that wasn't really of much help, but it can't do any harm. And strangely enough, even using 10 ohms, the volts drop was negligible. It's about 300 millivolts. So this circuit, left for the MOSFETs, uses virtually no current at all. So now where are we now? Yeah, other things I did, which improved the hum a fair bit, was I've got all my DC earth points at the center points of the two big capacitors, I'm using that as the grounding point. Previously I was using a star ground on the chassis, which is down there, for all the negatives and the mains earth. Now that was an absolute disaster, having a star ground on the chassis with mains earth. As soon as I plugged this thing in to any other piece of equipment that was mains earth, I got even more hum. So there was obviously earth loops in the mains earth causing problems. So what I've done now is I've completely isolated the DC earth, which is on the capacitors, and the AC mains earth, which is on the chassis. No connection whatsoever between the two of them, and that seems to, well, certainly cured the problem of plugging it into some other piece of equipment. Makes no difference at all now. Other things I had to do, the earth cables which go to the circuit boards were going again in front of the toroidal transformer, especially for this left one, and believe it or not, even that was a problem. So I basically rerouted them away as far as possible and all around the back, so that far away as possible from the transformer, and that improved things considerably. If we look back at this list, it got it down to, I don't know, maybe 0.05 microwatts. Now when you get into these sort of levels, it's really hard to do any measurements, but I found that my HP 8903 audio analyzer is good for this stuff. It has a 1 millivolt range, which will, with 3 digits of resolution below 1 millivolt. So that was obviously the way to go for measuring this stuff. And the last thing I did a couple of days ago, which has improved things even more, on that circuit board there that I built up for the pots. Also I had to put in insulated phono sockets, so they weren't connecting to mains earth on the chassis, because it's all no longer mains earth referenced. The other thing I did though, when you've got these two negatives coming off the phono sockets, they were going to a common earth point on this little circuit board, and even that was causing a problem, connecting those two earth points together at that point. I mean, effectively they're at the same DC potential, but obviously not at AC, so I had to cut a slot down there to isolate those two, and that has got me to where I am today, would you believe? If nothing else, I'm learning a hell of a lot about earth loops and hums and whatever. But what I've got it down to now is a disparity between the two channels. On the previous measurements, left and right channels were almost identical. They certainly were at 1 microwatt anyway. But now, on the left channel, I'm measuring 0.34 millivolts of hum or noise using the HP audio analyzer, which equates, would you believe, to 14 nanowatts of noise. And 14 nanowatts, or 0.014 microwatts, is a very, very small level. But believe it or not, if I stick my head next to my speaker, I can still just about hear that hum. Shows you how sensitive my speakers are. Now on the right channel, I've now got it down and to 0.1 millivolt, which is 1.25 nanowatt, and there's no way now that you can hear that on the speaker. it's just too far down in the, to actually hear. So even with headphones, I've tried headphones across the speaker terminals, and the 14 nanowatts on headphones is fairly loud, to be honest, on a pair of headphones, because you wouldn't normally stick headphones across a speaker output, because for one thing you're likely to blow them up if you've got a signal more than a few milliwatts. And anyway, the hum is still audible on the headphones, but on the right channel it's just a gentle hiss, which is what you might expect. So I think we're just going to have a look now and see what these measurements look like on the various instruments. Right, so I've now got my scope connected across the left channel, which is the worst one at the moment for noise. And I go over to the scope, zoom in a bit, and you can clearly see there is something there. And we're on, would you believe, 1 millivolt range. I can go up to 500, go down to 500 nanovolts, 500 microvolts I mean. So that's what we're getting on the left channel. I go over to the right channel. Now you can see on a 500 microvolt range you're just getting virtually nothing, just the odd spike. And go back to the other channel. There's no hope of reading that frequency on the scope, but if I go up to the HP audio analyzer, it's telling me I've got 100 Hertz noise level there, which is obviously coming off the full wave rectification. And as I said in my bit of paper, yeah, well, my bit of paper says 0.34 millivolts, but I'm getting 0.3 basically millivolts of noise. So that's one way of doing it. Sorry about that, catarrh as usual. And I didn't realise how good this audio analyzer is. It can measure down at those low levels. You can see it auto ranging. So it's got a resolution there of 1 microvolt on the far end. So let's go back to the right hand channel. No, wrong clip. Right hand channel now, and now it is struggling to make any sense out of that because it's so low in noise. And I also found there's a 30 kilohertz low pass filter. Without that you're doomed. You get all sorts of crap. But you put it in the, because you're only interested in the audio band anyway, you don't want to look at 30 kilohertz or anything above that. So now it's struggling to read the frequency, but it's saying the noise level is 0.1 millivolt. But when you get down to these sort of levels, I started to have confidence issues in my measurements. But it is what it is. But let's go back to the main box itself again. So I've now got my scope connected to the main ground point for the power supply, and I'm connecting on to the earth point, which is for the signal earth, which is the same potential. In other words, there's a great big thick black wire which connects all the way down the earth connections down the board. So in theory this should be identical potential to this point here. if we look on the scope, and this is on the good side, right hand side, at that side you can still see there is some slight noise between those points, which are effectively 0 ohms difference between them. And if I do the same thing on the left channel, getting onto that earth point, now we see this. Bearing in mind these points are at the same, should be at the same potential. They're both earth back to the capacitors, centre points of the capacitors. So we're getting a load of crap, aren't we, there? And if I freeze it and bring up my cursors, and what's that one doing? Let's do that one for a start on that cursor, and move that one in to there. That's telling me up on this screen here that that's 98, well, call it 100 Hertz. That's what that is. That's 100 Hertz. And I think similarly those big spiky ones will be the same as well. Well, we'll see. Yeah, still 100 Hertz. So that's the noise issue, is 100 Hertz. So get rid of cursors, don't need any more of that. And so there you go then. So what is the answer to this problem then? There's obviously still noise on that right channel. It's not a massive amount, obviously. But why? How does that differ from the other channel, which has got virtually no noise on it? That is my question, and it's getting to the limit of how do I improve it anymore? Tried moving these a bit, makes absolutely no difference. These wires near to the board, tried moving those around, makes no difference whatsoever. Could swap the two boards over, but I don't think it would make any difference. There's a lot of wiring to do. Could try where the earth wire is connected underneath the board. I could try moving that to a different spot, maybe nearer the front, to see if that makes any difference. I think that's what I might just try, to see if it does make any difference. I think we're dealing with all sorts of things, like obviously inductance plays a factor when you're working at these sort of low levels of signals. So I think I might just try that, and moving the earth connection to the bottom. It's on the bottom of the board. Okay, that's the underside of the board, and this is your main earth power supply earth wire, and it was previously just there. That's your speaker output earth, and I know it looks like a dog's dinner, this board, but it's more important how it works than what it looks like to me anyway. So I've relocated that earth wire to this point here now. So it's still on the same earth, but it's further down the track. So let's see what that does for it. Alright, board's back in. Let's turn it on. Oh, that's actually made it worse. That's pretty horrendous. So it does make a difference where you put that earth wire. Right, that's enough of that. So I moved that earth cable back to further on back on the circuit board, in a slightly different position to the original one. I think we're more or less back where we were before. So I don't think I'm going to improve that anymore by moving that earth connection around. So we look up at the audio analyzer, it's more or less the same, about 0.3 millivolts. So that's it, I gave up. I haven't got any more ideas about how to improve this at the moment. If anybody else has, please let me know. But strangely enough, I was watching this guy in El Paso on YouTube, calls himself El Paso Tube Amplifiers, and he specialises in valve amplifiers, building them, and he was doing a video on hum in valve amplifiers, and so I sent him my results of what I've achieved. Some of these figures, probably the lower one there, 0.03 microwatts, and he said, well, you've achieved something like 93 dB signal to noise ratio. I think you should be happy with that. So I think that's praise indeed, because he's been at this a lot longer than I have, and he knows far more about it than I do. I actually measured about 90 dB signal to noise ratio on the HP 8903. So there we go. So I think what I'll do is just take it back in the lounge and see if I can hear any hum on it now. So here we are back in the lounge, and it's wired up to my big speakers, and I've actually got them crossed over so the right hand speaker goes to the left hand channel, because I can't be bothered to walk over to the other speaker to test the noise, because I know there's no noise on that channel. And strangely enough, it's actually quieter when you plug a signal cable into it than it is with no cable plugged in. And I've got the signal coming out of my Marantz amplifier in there, which I modified to have a preamplifier output. So if I go over to this speaker, it's interesting that you get most noise at the mid-range unit, and I can hear that in my ear, but so very, very faint. I very much doubt you can hear that, but that's the 100 Hz, which you would expect to hear out of the big bass speaker, but it doesn't appear that's the way it happens in this situation. So just to confirm that it is all working, I'll turn the volume up.
BBC Radio 6 Music. BBC Radio 6 Music. 6 Music.
So there you are. That's about all I can do for now. But if anybody's got any other ideas about why I've still got that residual hum, please let me know, because I've reached the limits of what I can achieve, I think. So bye for now.